5.1 angles. We start off with the different types of angles, and you should already be familiar with this. Acute, we usually say less than 90, but technically it's between 0 and 90. A right angle is 90 degrees, and obtuse is between 90 and 180. I know a lot of the times we think of greater than 180 or greater than 90, but it's between 90 and 180. A straight angle is just a straight line, and that's 180 degrees. So we already should know that and remember that from geometry class. An angle has three parts, okay? An angle in standard position usually. The first part is called the initial side. And that's just basically one of the rays of the angle. And the second part is the terminal side. I'm big on the meaning of words. Can't draw an M though. Initial means starting, and terminal means ending. So I kind of look at it as like an angle is like an alligator's mouth, and you can open this alligator's mouth, I don't know, however big you need to make it. But initial means the starting side, and terminal means the ending side. And then other than that, there's this arrow. This arrow indicates the angle's measure. So those are your three parts, and you're going to have that pretty much on all of your angles, okay? You really want to pay attention to that arrow, because if the arrow goes around this direction, that would indicate a negative angle. Most of the time, it's going to go around in this direction, which would indicate a positive angle. So I'm talking about this angle. This angle to me probably looks like about 300 degrees, okay? But you could draw a similar picture with a negative angle and say that's like negative 60 degrees. And so they might seem like the same angle, but we represent one of them as a positive number and one of them as a negative. You really need to pay attention to that arrow. Example 1, finding the complement and the supplement of an angle. So those of you who don't pay attention to words are going to struggle with problems like this, but it's really not very hard, assuming you remember those definitions. So we've got this word complement. You should probably remember complementary angles from geometry class. Complementary angles sum or add up to 90 degrees. Supplementary angles. Anybody remember what supplementary angles do? Right. Sum to 180 degrees. Memorize that. Okay, you need to know that. You need to have that. Okay, because there's going to be questions that ask you about a complement or a supplement. It's going to come up. Okay. So on this question, example 1, all we have to do is it says, okay, here's an angle of 40 degrees. We need to find its complement. So think about complement means adds up to 90. Adds up to 90. You should be able to do this in your head. What number is going to make 90? 50, right? Because 50 plus 40 equals 90. Don't think too hard. Don't overthink this. It's supplement. You're thinking, what's going to make 180? What number makes 180? Well, it's got to be 140 because 140 plus 40 equals 180. Okay? It's aggravating the number of people that miss that. Okay? But you have to know the words. Don't get them mixed around. Sometimes people will get them backwards. Okay? So example 2, finding measures of complementary and supplementary angles. I guess the first thing you're supposed to notice is that this is a 90-degree angle. We see from the picture that this is a 90-degree angle. That means complementary, right? These are complementary. And so all you have to do to find the measures is say, well, I know that this 6x and this 3x are going to add up to 90. So it's an algebra equation. 6x plus 3x equals 90. So we can solve that algebra equation. Like terms, give me 9x is 90. And divide by 9, you're going to get x equals 10. Now, that does not answer the question because it says find the measures of the angles. So the first angle is 6 times x, or 6 times 10. So this one is 60 degrees, right? And 3 times x, or 3 times 10, is 30 degrees. So those are your answers. 60 degrees and 30 degrees. Okay? So then the other one is really the same question, only this time you're supposed to notice that this is a straight angle. We have a straight angle, and so we know a straight angle is going to add up to 180 degrees, okay? These two things, 4x plus 6x, add up to 180. So just do basic algebra here, like terms, 10x equals 180. Divide by 10, and x equals 18. That's not the answer to the question, though, because it wants the measure of the angles. Well, this one is going to be 4 times 18. What is that, 72? And this one's going to be 6 times 18. Help me out here. 60 plus 48 is 108. This one's 108. And you can check your answer because notice what those two numbers do. Those two numbers add up to 180, right? So that's a good way of checking your answer. But these answers would be 72 and 108 degrees. Make sure you put the degrees. It's a unit. You always include units. Questions? Now, here's a part that's kind of tricky, I think. Okay? Degrees, minutes, and seconds. Hundreds or even thousands of years ago, before they had calculators, okay? They didn't know how to do a lot of really tough I'm not saying they didn't know how to do them, but they didn't have calculators to do their tough calculations, okay? And in fact, they didn't even use base 10. They used base 12, okay, which is a really foreign idea, and you'd almost have to have a complete different lesson for base 12. But if you look at a clock, the clock has 60 minutes in it, and that's based off of base 12. That comes from ancient math, basically. They liked base 12, and they liked 60 because it was easier to work with fractions, all right? It's kind of hard to work with fractions without a calculator sometimes. And so they used this base 12 and they used this 60 to simplify their calculations, I suppose. Okay? So when you see degrees and minutes and seconds, understand that minutes and seconds is just like decimals, kind of. It's indicating a part of a degree. So 1 minute is 1/60th of a degree. So it's kind of like a minute is 1/60th of an hour, right? It's the same kind of numbers. It's the same kind of calculations. Or 1 minute is 1/60th of 1 degree. Probably easier to think about it as 60 minutes equals 1 degree, just like 60 minutes equals 1 hour. Okay, 1 second is 1/60th of a minute, and so you can write it like this, or you can say 60 seconds is 1 minute, or I guess you could even say 60 seconds is what? No, I'm sorry. I shouldn't have said it like that. I should have said like this right here. 60 seconds equals 1 minute. But this right here says 3,600 seconds equals 1 degree. Okay? There are 3,600 seconds in an hour. It's kind of the same exact calculation. So all we're trying to do is we're trying to deal with decimals. Okay, historically speaking, they didn't really know how to deal with decimals, or they didn't have calculators for decimals, so they used this. This was easier for them. So if I said 42 degrees and 30 minutes, okay, that decimal, it looks like there's a decimal just because my pen fudged there for a second. Why can't I erase? 42 degrees and 30 minutes. Think about it. As a decimal, 30 minutes out of 60 minutes, that's like 0.5. So that's saying the same thing as 42.5 degrees. It's the same thing. 42 degrees and 30 minutes is just 42.5. Now, I know that probably everyone in this room understands 42.5 better, okay? But think about a time on a clock, okay? If something took 2 hours and 30 minutes, that's what you would say. You wouldn't say 2.5 hours. You'd say 2 hours and 30 minutes just because it's easier in that context. So imagine thousands of years ago, it was easier for them to talk about degrees and minutes, okay? So another example, if I said 12 minutes and 15 seconds, you could think about that as 12 point. Notice 15 seconds is 1/4 of an hour. So you could say 12.25 minutes. Okay, 12.25 minutes. All right. So we need to perform each calculation. Basically, this is like terms. So 51 degrees and 29 minutes. Think about it as just combining your like terms. That says 51 point something plus 32 point something. Okay, you're just adding parts. But think about it as like terms. Let me get a calculator going here. Okay, I'd say 51 plus 32 is 83 degrees, and then 29 plus 46 is 75 minutes. Okay, now that's a little bit weird. We wouldn't tell time like that. I wouldn't say something is going to happen in an hour and 75 minutes. Anytime you get past 60, you kind of have to shift things around, right? Instead of saying 75 minutes, you might say 1 hour and 15 minutes, yeah? Okay. So anytime you get a number like that over 60, you're probably going to want to shift and say that's like saying 1 degree and 15 minutes. So if you kind of recollect, you have 83 degrees and 1 more degree. You have 84 degrees and 15 minutes. Okay, so it's just like terms, and then you're going to have to recollect. Okay. Now, subtraction is harder. Okay, subtraction is harder because in this case you're going to have to borrow. There's no like terms from which to subtract the 12 minutes. Okay, so what I would do in this case is instead of thinking about this as 90 degrees, I might think of this as 89 degrees and 60 minutes. Oops, that's seconds, minutes. Okay, think of that as 89 degrees and 60 minutes. That way, you can subtract. You do have like terms. So 89 minus 73, put your like terms together, is 16. So I see 16 degrees. And then 60 minus 12 is 48, right? 48 minutes. 16 degrees and 48 minutes. Done. Okay. Example 4, we're going to have to convert. And this is probably the hardest thing of the lesson, I think. Okay, so far, for sure. Convert 78 degrees, 8 minutes, 14 seconds to decimal degrees. Okay. Now, before we start, just think about what that means. That means 78 point something, right? 78 point something. Okay. If it was 78 degrees and 30 minutes, that would be 78.5. So this is definitely less than 78.5. Okay. So we go back and we look at these conversions, and I treat it kind of like I would treat a chemistry problem. I do some conversions. I know 60 degrees. 60 minutes equals 1 degree. I know 60 seconds equals 1 minute. I know 3,600 seconds equals 1 degree. I've got a couple of different conversion factors. It wouldn't hurt for you to have those memorized. You probably already do, except for maybe this one. 3,600 seconds in 1 degree. So what we end up doing is saying like, okay, I'm going to write a lot, and then I'm going to show you the shortcut. Okay. So if you take 8 minutes, you can do a conversion and say there are 60 minutes in 1 degree. Okay. The point of that, I put the minutes on the bottom because I know the minutes would cancel this minute. Okay. So that's kind of my long way of doing it. But my shortcut way is going to be this. I'm just going to say this is over 60. See how the 60 is on the bottom? The 60 is on the bottom of that calculation, of that conversion. That means divide by 60. Okay. In a similar way, if you've got 14 minutes, you can say, well, I know there are I said minutes, that's seconds. 14 seconds. I know there are 3,600 seconds in 1 degree. Okay, I'm trying to do that conversion. I want decimal degrees, which means I want it to be just degrees. So my shortcut is I'm just going to divide this by 3,600. And then what I have to do is I would take a calculator and I would add 78 plus this. Okay. So the answer is going to be 78 plus 8 over 60 plus 14 over 3,600. 78.137 repeating. Okay. Notice, like we thought, we knew it was going to be 78 point something, right? We knew it was going to be less than 78.5. So here we are, 78.137. It says round up to the nearest thousandth, so 137. 78.137 degrees. You can put a little squiggle there if you want to show that that was rounded off. Okay. So then, part B says convert 34.817 degrees to DMS, degrees, minutes, and seconds. Okay. We're going the other way. All right. We're going the other way, and we're going to need to convert this to minutes and seconds. We already know this is degrees. It's definitely 34 degrees and something. Okay. I already know the degrees part. The degrees part is 34. Don't overthink this. Don't do anything with that. Okay. It's the 0.87 that I have to change. Okay. It's 34 degrees and something. So I'm going to do a conversion, but I'm going to go the other way. So check it out. You've got 0.817 degrees. And we want minutes. Okay. So we want to go from degrees to minutes. Again, you go back to these conversion factors. Degrees and minutes, that's right here. I know 60 minutes is 1 degree. So I use that same conversion factor. I put degrees on the bottom so it'll cancel. Okay. So I've got 0.817 times 60 is going to give me my minutes. So 0.817 times 60 is 49.02 minutes. Okay. And at this point, I know the minutes is 49. It's 49 minutes. And the 0.02 represents the seconds. Okay, that decimal part represents the seconds. So I do the same thing. I need to do another conversion. So let's convert the 0.02 minutes. Okay, that's 0.02 minutes. Use your units. The people who refuse to show units are the people who won't get this because you'll get confused. Always show your units so you can always be sure of what you're talking about. So I need to go from minutes to seconds. So here's my conversion right here, minutes to seconds right here. 60 seconds equals 1 minute. We know that. You already know that. So you do that conversion and you're thinking, I want to cancel out minutes, so I'm going to put minutes on the bottom. 1 minute is 60 seconds. I'm trying to get seconds here. Okay. So the minutes cancel. I'm just going to multiply 0.02 times 60. It's 1.2. 1.2 seconds. That's this. So you've got your answer now. Your answer in DMS, okay, 34 degrees, 49 minutes, 1.2 seconds. Sometimes they'll have you round off your seconds, but in this case, that's what we've got. 34 degrees, 49 minutes, 1.2 seconds.